So welcome everybody to our fifth in this series of HeatSmart Tompkins installer case study webinars. This week we have with us Kevin. How do you say your last name, Kevin?
Seagate.
Seagate. Okay, I
Yeah.
usually say Seagate. It's Kevin Seagate from NP Environmental. And they're doing a great case study with a home that recently got a grant that paid for a whole new heating and cooling system replacement with some Mitsubishi air source heat pumps. We're going to hear from Kevin in just a minute. But first, I'm going to kick off with my presentation, a little bit about the HeatSmart program and the importance of heat pumps and weatherization and the role in climate change. And then we'll kick it over to Kevin to present on this case study, and then there'll be time for your questions at the end. So I'm gonna just share my screen real quick and we'll get started here. So as I said, my name is Lisa Marshall. I'm the program director of HeatSmart Tompkins. We serve Tompkins and Chemung counties. And we are a community nonprofit. We don't make any money off of any sales. We just are here as to do education, outreach, and support to the community to understand home and building energy efficiency and how they can heat and cool, heat hot water, and stay more comfortable in your home. We like to emphasize what we call the 3 C's: the cost savings, the comfort, and the climate solutions that you can enjoy through converting to energy efficient heat pumps. And also the 4th C that we added more recently, which is convenience, which I can talk about in a minute. So we are one of about 20 NYSERDA clean heating and cooling communities, or most of them calling themselves HeatSmart. And you can see in this map that now that we have so many of these clean heating and cooling community programs, most New Yorkers are now served by one of these programs, which is very exciting. NYSERDA is the New York State Energy Research and Development Authority. And they are funded by all of us every month when we pay our NYSEG bill or our utility bill. We pay a little fee called the Systems Benefit Charge, and that funds NYSERDA. And so NYSERDA in turn funds our program. So thank you so much for paying my salary. And the other reason I love to show this slide is that HeatSmart Tompkins was the very, very first pioneering clean heating and cooling community, or HeatSmart program. We actually were just a community-based, self-funded program. And NYSERDA loved what we were doing so much, they decided to fund us and create a program based on the idea of doing this grassroots community outreach about home and building energy efficiency and electrification. So we're really, really proud of that and see how it's grown across the state and even to other states. But why is such a thing as a clean heating and cooling or HeatSmart community program even important? Why do we need that? And the reason that we need it is because we find ourselves in what some are terming the climate crisis or the climate emergency here on our spaceship planet Earth, where we rely on this blanket of gases in the atmosphere to keep life livable and comfortable for us and all the other species we cohabitate with here on the planet. And unfortunately, things in that atmosphere are a little out of balance. And the reason for that is that for the past 200 years, since the onset of the Industrial Revolution, each year we burn more fossil fuels than the year before, putting more carbon dioxide, methane, and other gases into the atmosphere. So that blanket, that lovely blanket of atmospheric gases is getting to be too warm, which is causing all kinds of problems that you all probably all know about: extreme weather, sea level rise, et cetera, et cetera. So it's very important that we figure out how to reduce emissions. And here in New York, we actually have a law that requires us now to reduce emissions from all the sectors that produce these gases. That law is called the CLCPA, or Climate Leadership and Community Protection Act. And it requires us to reduce emissions pretty dramatically, which is quite exciting. This is a nation-leading law. So when we have to figure out how to do that, we have to look, where are these greenhouse gases coming from? And as this graphic shows, that our buildings are about a third, producing about a third of the greenhouse gases. And actually, there's a good argument to be made that this green building icon should actually be bigger than this car if you count all of the emissions that happen from natural gas before it gets to the building. So as many of you know, the natural gas leaks from the moment you start taking it out of the ground and moving it around, and it's a very potent greenhouse gas, that methane. So if you include that, then this building, imagine it just growing and being quite a bit bigger than the car. And that's why we're at HeatSmart, we think it's really important to tackle the building space. So how do we do that? Well, we have to look at how we use energy in our buildings. And here in New York, although it's been a very warm fall so far, we are a heating dominant state. And so heating is the main way we use energy in our homes. And it accounts for more than half of the energy used in the house. So thinking about how to heat more efficiently is super, super important. And then also heating hot water. This graphic from Minnesota says 15% of the household energy use is heating hot water. I've seen numbers between 15 and 20% for New York. So, it accounts for, maybe up to a fifth of your home's energy use. So at HeatSmart, we like to look at both the heating and the hot water in particular. So we have several recommendations for people who are starting to look at those things. One is that you first have an energy audit and take a look at the insulation and the air sealing that is going to keep that heated air or cooled air in the summer, if you use air conditioning, inside the house with you, instead of letting it go out the window or through the roof or through the recessed lighting or out through the foundation. That's where the heat often escapes and cold air seeps in. And so it's important to take a look at your building envelope, is what we call that, and have your house weatherized, which weatherization is kind of a blanket term that covers insulation and air sealing. And then the main thing that we talk about at HeatSmart is we're thinking about heating, and we have recommendations for that too. The wonderful technology known as the heat pump, which is super duper efficient because it's taking heat from the surrounding atmosphere, from the air or the ground, and moving it around so that you can use it in your house. And because you don't have to create that heat, you just have to move that heat around. That's where all the efficiency comes in. So there's two basic types, the air source heat pumps and the ground source heat pumps, and we'll talk a little bit more about those. And then that same heat pump idea can be used to heat your domestic hot water. So these are all much more efficient ways of producing, well, not producing because they're not producing heat, of delivering heat to your home or building. And as an added benefit, they also provide cooling and air filtering and dehumidification. So heat pumps are just great little things to have. So when I talked about insulation and air sealing, I like to just show this graphic. Insulation is like this warm sweater here on the left, which is a nice warm wool Irish sweater that this fellow is wearing. But when the wind blows, that sweater, even though it's a warm sweater, can still let cold air in. And anybody who's walked outside on a cold day wearing a warm sweater might have felt that freezing cold air hit you right in the belly. And so it's still not adequate unless you pop a windproof windbreaker on over the sweater, like this fellow has on the right. So that sort of represents the air sealing that seals up the cracks and keeps the cold air from leaking in, which can happen, in a lot of places in your house, around windows, around joists, around electric outlets, and et cetera. So those are important things to have evaluated and fixed if possible. And then turning over to the heat pumps, I just like to show these pictures of some of the different kinds of heat pumps that we often see put into homes. It's all the same technology, the same basic chemistry and physics that runs these heat pumps. As I said, what they do is they have a closed loop of a refrigerant chemical, and that chemical is very susceptible to phase change. So when you put it under lower pressure, it evaporates, and when it evaporates, it absorbs a ton of heat. And then when you move it through the system and you put it under higher pressure, it condenses and it gives off heat. And the simple physics is actually what keeps the inside of your refrigerator cold, but it can also be used to heat or cool your whole house. So here on the left, we have a typical air source heat pump. This type is known as a ductless mini split. So this is the outdoor condenser unit, and then this, what you can see here is the refrigerant line coming off of that, and this white thing hides that line set. It goes in through the wall of the house and delivers warm air through an indoor wall or floor mounted unit. And then that whole system can be run in reverse to deliver air conditioning in the summer. The ground source heat pump here in the middle, and NP Environmental, who's here with us today, is one of our leading installers of ground source heat pumps, is sort of what I consider the gold standard. The heating exchange happens in the ground, which all year round is about 50 degrees. So it's extremely efficient. If you can imagine the difference with the air source heat pump, it has to extract heat from the air even on a negative 10-degree day. It's going to work pretty hard to do that. It won't be super efficient in those super cold temperatures. But the ground source heat pump is less susceptible to that because the ground is the same temperature. And then the heat pump sits inside your basement, and that's going to last a lot longer. It's a really solid piece of equipment, and it's protected from the elements. So these units can last, at least 20 years, 25 years. I've seen them still going after 30 years. And it distributes the heat through the distribution in your house, whether there's various ways. That most common is forced air, but there are other methods to distribute ground source heat pump heat. And these systems can also heat or preheat your hot water. And then over here on the right-hand side, I have the little standalone heat pump water heater. This is basically an electric resistance water heater like you just might already have in your home or you've seen, but with the addition of this little heat pump guy on top that preheats the water, and that allows for increased efficiency. These are great units. They don't work in every home, but for the homes that they work in, they're really terrific. And there are incentives, grants, rebates, and tax credits that apply to all these different technologies, and HeatSmart and your installer partner can help you access those and find out what you qualify for. So that's my little spiel. After that, I'm going to introduce NP Environmental. And first, I'm going to show a little video about NP Environmental that we made. Gosh, I think it was, Kevin, might even have been before you started working there. It was a couple of years ago now. We need to make a new one probably. And if the video is buffering and the sound isn't good, I'll just stop it. So give me let me know, Kevin, if it's not good. I'm hoping it'll be good. So let's go to the video.
Hi, my name is Nick Pryputniewicz, co-founder of NP Environmental. We are a sustainable technologies company located in Waterville, New York. We're actually here on location at our shop, and we focus on sustainable technologies. We specialize in geothermal heat pumps, air source heat pump hot water heaters, ventilation systems, and air purification systems. It's our belief now, as it was long ago back in 2004 when we started the company, that every building, every home, every industrial process, every operation that operates between 35 degrees all the way up to 135 degrees is a perfect fit for 400% efficient 3-in-1 heat pump technology. And the team here at NP Environmental can help you with answering that question of how you can achieve that 400% efficiency and how you can put it to work for you to reduce your operational costs, reduce your carbon footprint, and have long-lasting operation that requires very little maintenance, and it gives you superior comfort through your home. So looking at the equipment that we utilize within NP Environmental, one of the things that we like to focus on is vetting the equipment that we install. The equipment is the backbone of your system, and it's important to have a good quality piece of equipment, a good reliable piece of equipment, a quiet operating piece of equipment, and mechanicals that are going to last forever. Because when you're investing in geothermal technology, you're not only getting the benefits of cost savings, average savings is about 60%, you're not only getting the most comfort that you can achieve from any system, but you're also getting something that lasts forever. And when you look at this technology and what it does for the environment, the reduction in the carbon footprint, the benefits are just through and through. And you look at today and you look at the condition of this planet and you look at society, this is truly the best technology for the future. So when we talk about the different types of heat pumps, I wanted to take a minute to step outside here, and as you can see, I'm standing on a beach in front of a pond. And this pond actually serves as the earth loop for the building behind us. Now this pond stays a nice stable 46 to 50 degrees, and that offers us good heating and good cooling for the building behind me. And at NP Environmental, we're firm believers in utilizing the resources around you. And what better resource to use around you than the land and the power beneath your feet? And when you talk about HeatSmart programs, promoting these technologies, looking at heat pump technologies, we've been there since the beginning. I remember back before HeatSmart programs even started, we were trying to do community gatherings, educational type events, but we didn't have much success with it. And now you're starting to see great success, and heat pumps are starting to take hold like never before.
Alrighty. Well, welcome, Gina. We have a small group today, but we decided to just go ahead, and we're live on Facebook and recording so people can catch up if they missed this. And Kevin, without any further ado, I'll turn it over to you for the case study.
All right, thank you. So I'll start by sharing my screen here, I guess. That was a good video. I don't think I've ever seen that, actually.
Thank you. My son made all those videos, so it's good to have an in-house videographer.
Yes, definitely. All right. Is that the full PowerPoint screen that you're seeing now?
Yes.
It's coming up okay? All right, perfect. All right, so good?
Yep, take it away.
Okay. All right, so here's my title page. The case study I'm presenting on today was a project that that I designed and managed in Tompkins County through the HeatSmart program. I chose this project for a few reasons. It was one of the early on grant programs that we had totally funded for this customer. And so that was a good experience for us, and definitely for the customer, and really for the program as a whole to be able to kick off that grant program and have some success with it for the HeatSmart program, for the installers and for the customers. I also chose this case study because it's one of my favorite ways to configure an air source heat pump in the specific situation that this home and this customer was experiencing. And the third reason I chose this is because I don't elaborate very much on the insulation work, but we were teamed up with an insulation company and we offered a full comprehensive solution for this home to make sure it was properly insulated, air sealed, and had a very efficient, very effective HVAC system and hot water heater. All right, next slide here. I've got a little slide here to introduce NP like we typically like to do with these case studies up front. I'll breeze through this pretty quick because that video pretty much covered it all. We started back in 2004. I believe Nick mentioned that in the video. We're a design build company, so we're there start to finish, from the assessment to the quote to the contract, design, project management, install, commissioning, rebates. We cover all of that, anything dealing with heat pumps. And that's all we do. That's you know, I'm an energy auditor. I offer the comprehensive solutions with insulation, but our main focus is heat pumps. That's what we install the best. That's what we stick to. We don't do propane or oil systems, and any insulation. You know, again, we believe that that's best suited for the guys that focus on that, and we can make recommendations and offer it, but ultimately The insulation guys are going to offer you the best insulation install, and the heat pump guys are going to offer you the best heat pump install. So that's our philosophy there. And that's what we've been doing from day one. Nick talked about the 400% efficiency, anything from 35 degrees to 135. And I want to elaborate on that a little bit. He was standing in front of a few heat pumps at our shop in our office building there. And yeah, and we use heat pump technology for a variety of things. We heat the office, we cool the office, we heat the shop, and there's actually a manufacturing process in this building too for another company that requires a large cooling press that is run off geothermal. So it's can be used in so many ways, and the air source heat pumps offer a lot of versatility as well, which I'll talk about. So I'm going to move on to the next slide here. This is David Katz Home. I'm glad that I'm presenting this today. The house is covered in snow. We had a little bit of that this morning. So we'll all get ready for that coming up pretty soon here. Katz was, he was a new homeowner, just bought this place and was, kind of taking it on, trying to make the most out of his new home that he could. And so that's really a reason that I'm super happy that we were able to be the ones to work with him and, kind of make some of his dreams a reality with a high efficient HVAC system and some insulation improvements. He was qualified for the Empower grants. And so through the heat pump pilot study that was going on at the time, these grants are, they've been changed through some different programs. They're limited. They're sometimes available, not always. The rebates have been around for a while and will be around for a while, but this grant program lasted for the better part of 2021. And the specific grant program is over now, but we did this project in the early spring, late spring, early summer. And so being qualified for the Empower program through NYSERDA, we were able to get a grant for the heat pump system that covered the entire cost, and the installation was covered for the entire cost under Empower as well. All right. Here's his old propane furnace here. And it, you can see some of the stone foundation there. This was an 1850s house. Old ductwork, old furnace and even older ductwork that was probably tied into a older furnace even before that. Something I commonly see, especially in houses from that time period, 1850s, is there might be ductwork that's even in half decent shape, but really is only covering the first floor, and there's not much ductwork, certainly not a sufficient amount around the second floor, and not really any great ways to get additional ductwork to that second floor. So that's where the versatility of the air source heat pumps is going to come into play, which again, I'll elaborate on further once we get talking about the system. Okay, here's one of his outdoor units. This was a 2.5 ton Mitsubishi split system. So the way the system came together is what we did is we installed a 1-to-1 forced air unit, which covered his entire first floor of the home. We plugged it right into the existing ductwork. We did some duct upgrades where more air was needed in certain rooms or certain areas of the house. And so that ducted system, which was also an air source heat pump based system, that covered the entire first floor. Now the second floor had 3 primary rooms, bedrooms. And so those were all covered by this outdoor unit, feeding 3 ductless mini split heads, high wall mount units in those 3 bedrooms. So where the ductwork wasn't able to provide adequately for the home, we were able to cover that. And that's a common solution that I like to practice on some of these older houses. It tends to work out great. It saves the customer money where they don't have to buy too many units for the downstairs, and they can take advantage of their existing ductwork, but they still get the improved comfort with those wall units around the second floor where they're needed. All right. Here's some photos and some descriptions of the equipment we used. You can see in that top photo, there's an example of a high wall mount ductless unit in the main bedroom there. In the bottom right, that's a photo kind of from the backside corner of the ducted unit. Nice, slim, modern forced air unit. And again, we adapted and plugged that right into the existing ductwork. You can kind of see the adaptions there from what it was. And then, of course, on the bottom left, there's the heat pump hot water heater. After we were able to tighten up that basement, it had sufficient air volume, and it was going to maintain a good temperature down there to run that at a good efficiency, and save a lot of money there. All of the Mitsubishi equipment we install is very quiet, very efficient. And good quality, good warranty with them. They last a long time, minimal issues, and yeah, they're great products. So here's the results of the system. There's another photo of the front of that forced air unit in the new ductwork, and you can kind of see, again, I didn't really elaborate too much on the insulation here, but you can see some of the insulation bleeding over there in the right side of the photo. That's a crawl space, so we did an encapsulation of the crawl space on that side, and then we did some insulation in the attic parts as well. But that's going to make huge improvements to the heat load, to the comfort of the home. Shouldn't have any cold floors anymore, and big cost savings too. So total cost of the system was $26,150. Those numbers aren't too reflective of current prices with the increase of everything in the last year. But that's what it was at the time for all that equipment. And the breakdown was basically, well, I'm not sure, I should have shown that breakdown, but typically it's like 2/3 came from the grant and about 1/3 came from the rebate that everyone's eligible for. Annual savings expected from the HVAC system alone was $1,500. And I expect with the insulation upgrades, it would actually be a lot more. And of course, to have otherwise replaced that propane system, probably would have been looking at about $8,000 for that. So saved some money there too on that side. No expense to the customer, instant savings, instant benefit, worry-free reliability. And now he's got the benefit of air conditioning, dehumidification, high efficiency heating, even temperature throughout the home. Much better system than he was working with before. And that's what I have for today. So I'm open to questions at this point. Thank you for listening.
That was great, Kevin. You want to unshare your screen so we can see each other?
There it is.
And so the only thing missing from that was you forgot to introduce yourself.
I'm Kevin. I'm a field engineer at NP Environmental. So I work in doing the home assessments. I do the quoting, the contracting, the project management. I'm the guy start to finish.
Yeah, and Kevin was brought on a couple of years ago and has really stepped up to be Nick's right-hand man for at least the HeatSmart program projects. I don't know what happens with the other projects, but we're working on Kevin to sell himself too, because he forgets that part. So that was a great project. You said, Kevin, that it was one of your favorite configurations for an air source heat pump system. You want to sort of talk through what some of the different options are and why this one was one of your favorite, and then we'll take questions from our guests, but I wanted to hear more about that.
Yeah, that was really one of the main points that I wanted to make and kind of why I chose this system. Because it really is, I mean, I love being able to offer that solution. So with the air source heat pumps that we offer from the NP Environmental, there's a variety of different outdoor units to select from. Each system is comprised of outdoor units and indoor units. The outdoor units, they tend to come more as recommendations from me. Pretty much any project that I quote, yeah, any given project, I would have 2 or 3 designs for in my notes, and then I recommend whatever the best solution comes out to be from the design softwares I work with and the different scenarios that I run. Um, but of course, all of that is only coming from the size of the system, from the details I've observed in the home, and the input I've gained from the customers for what meets their personal needs and the needs of their home the best. And then I put that together again in 2 or 3 different scenarios and basically offer the one that makes the most sense for efficiency, cost, and practicality. So we offer those ducted units that I showed in the presentation, the high wall mount units, and then there's also floor mount units. Typically, that's like an upgrade option from the wall units. It's another ductless type system. They are a little more expensive, but some homes tend to have lots of wall art and shelves and, you know, not much furniture, where a floor unit makes more sense. Other homes have, you know, furniture and bookcases and bare walls, so the wall units make more sense. It's all really boiling down to what makes the most sense for the customer and their home. I guess to go into the ducted versus ductless a little bit would be the ductless units have the advantage of individual zone control. So each wall unit, like I said in Dave Katz Home there was 3 bedrooms in the upstairs. Each one got its own wall unit. And what that means is that each bedroom and each user in that room will be able to set their own preferred temperature. One room might be 68, one room might be 70, one room might be 72. And that's fine to do with those units. Whereas then the ducted unit on the first floor, that's going to have an advantage of being able to distribute the heat more evenly. So every corner of the house, every, you know, half bathroom has a supply vent. There's return vents spaced properly throughout to make sure that the heat is delivered as evenly and equally as possible throughout that first floor. Whereas with the ductless units, you're looking at a single source, kind of like, I mean, not as aggressive, but like a wood stove on one side of the house, the far side is going to be a little bit colder. It's certainly not that comparable because it's a lower, more even temperature to begin with, but that's kind of the difference there.
One thing I love about that configuration is if you should have a malfunction with one of the units, you're not going to lose heat for the whole house, right? Your pipes aren't going to
Yeah.
freeze. Like, you're not going to be in terrible shape until you guys can come out there and fix the problem. And sometimes I do worry when I see configuration with a whole ton of heads off of one branch box, and I feel like, wow, if something goes wrong with that branch box configuration, then the whole thing's down until it's fixed. So I do really like when I see often from you guys a similar even if you're doing all ductless, I often see Nick do like one on one side of the house to the downstairs and one maybe on the other side of the house to the upstairs and things like that, that I think gives a nice little bit of redundancy.
Yeah, that goes back to the practicality and the efficiency as well. Typically, you get better performance out of more outdoor units. Not that you want to, you know, load the house up with a bunch of single zone systems, but if it's a medium to smaller house, but there's really kind of like 5 rooms, you know, 4 bedrooms and a living room that you want to have covered, maybe the properly sized outdoor unit can only support 3. So to get the right number, you actually have to split it into 2 outdoors to make sure that you're both sized properly and that you're covering each room with however many ductless units the customer wants. But it is also better performance too. The only downside to that configuration is slightly higher upfront cost, but the rebates tend to offset those for the most part. So
Yeah.
it's normally not too damaging.
Well, Kevin mentioned that this customer qualified to get a completely paid for heat pump system, and that program. It was a pilot study that NYSERDA did, is over, but there are grants now that give the same grant amounts until those run out. And then we just learned yesterday, it's not even really public yet, but there is going to be coming quite a large amount of grant money for low income households to get heat pumps. So you haven't missed out on what, even though the exact same program that the Katz family got their heat pump through, it doesn't mean that low income folks are out of options now if they're interested in heat pumps. And as you can see, luckily the Katz family didn't have to, but if they're saving $1,500 a year, and some people save even more converting from propane to heat pumps, it can be very worthwhile even to get the low interest loans to finance those and put them in as well. All right, well, welcome to our guests, Gina and Cassie and Bruce. Nice to see you. And what questions do you have for me or Kevin? This time is yours.